I'm Mishav, and this is the solution to the problem schedule. In this problem, we have a building in which there are n offices, and in each office there are two people, A and B. And now we have restrictions that on each day only one person can come into each office. So for each of the days, we have to choose which person will enter each office, and we have to produce a schedule like this for a specified number of days. And now what we are going to be looking at is people from different offices being in the building together and being able to collaborate. So for instance, on the first day of our example schedule, in office 1 and in office N, there is person 1A and NA, and the same two people will meet again, let's say on day 4 of our schedule. So these people had an interval of length 3 between two consecutive meetings. And now the statement is defining in some convoluted way the maximum is isolation in terms of iterating over all possible pairs of people from different offices and taking the maximum over the intervals between consecutive days in which they are both together in the office, and they are supposed to minimize this value. And if we actually work out through what this definition is trying to tell us, we will be able to simplify the problem to the following. So we are looking for the minimum number of days such that each pair of people who are not working in the same office will meet at least once. So this is what we are trying to accomplish. And how can we do that? So for each office independently, imagine that we will find the subset of days on which person A is in this particular office. And now let's look at this collection of subsets. What can we tell? We can tell that none of these, so all of these subsets have to be incomparable in any valid schedule, because there has to be a day when there are both A's, so the day where both of the subsets have an element. There has to be AB, there has to be BA, and there has to be also BB. So the full and the empty subset are banned, and with this restriction we are trying to maximize the number of incomparable subsets. So essentially we have the lattice of all possible subsets, and we are trying to look for the maximum anti-chain in this lattice. This is called a Sperner family, and we know that the maximum size of such a family is n over the floor of n half, and this is achieved by taking all of the subsets of size exactly floor of n half or exactly ceiling of n half. And armed with this observation, we can now do the construction very easily by just iterating using, let's say, an next permutation in C++ over all subsets of one particular size, and we can prove that this will give us the optimal schedule.